Okay, so I have copied this into the shell file. So if you download a second copy and then copy paste this into your Excel file, then you will have it. So here, this ANOVA table has only two values entered here: the mean square of the model, which is regression. So mean square regression is given, and then sum of squares of error is given. Okay. Then it also gives how many observations there are. Okay. So we have a multiple regression model that has been developed with a sample of data of size 50. So that means our n is 50. Okay. So with n being, if n is 50, then you know that the degrees of freedom for total is what? Exactly, n minus 1, right? N minus 1. So n minus 1, so we have that. Then it says there are 10 independent variables. Okay, 2 of the 10 independent variables are qualitative variables, or nominal or ordinal, right? With 3 and 5 levels. So how many variables are in the model? Okay, so that would be our degrees of freedom for model. Okay, so there are 10 independent variables, out of which 2 are nominal or qualitative. So that means there are 8 interval variables. Okay, there are 8 of them, and then we have the 2 nominal variables or qualitative variables, for which we have to define dummy variables, right? So how many dummy variables are needed for the first one? The number of levels for the first one is 3. So how many dummy variables do we need for the first one? It's 2. Okay. Dummy variables for the second qualitative variable is 4. So now the total number of variables or number of predictor variables is 8 plus 2 plus 4. Okay, 8 interval variables and 2 dummy variables for the first qualitative variable and 4 dummy variables for the second. So total number of predictors is the sum of these, and that is the degrees of freedom for model. Alright? Okay? So now the difference, the error degrees of freedom is n minus p minus 1, so that will be that minus that. Okay. So once you have the degrees of freedom, then we can find the MSE like that. Then the ratio of these two will be your F. So MSR divided by MSE, that's our F value. Okay. Then how do you find the P value? Okay, so from F statistic we have to find the P value, and that comes from the F distribution. So Excel has a function, there are 2 functions, fdist and fdist.rt. And RT stands for right hand side. So when you have a F distribution is a distribution that's only on the positive side. So it's something like this. Okay. Now, if this is the F calculated value, that's a P value. Okay, and this f.this.rt will give you that value. So use that function, and that has three things that you have to provide: the value of f itself, so that's the first one, and then the degrees of freedom, two of them, the numerator degrees of freedom and the denominator degrees of freedom. Numerator is MSR, so that's the degrees of freedom for numerator, and then we have denominator degrees of freedom, which is the degrees of freedom for MSE. So that will give you the probability. So 0 here means it's really very close to 0. So p-value cannot be 0, but it is really, really small. Okay, so if you use scientific notation, then you see there is 36 zeros, and then we have a value. But anyway, so let's put it back like that. Alright, so now there is only one thing that's left blank, that is our SSR, sum of squares regression. Remember, mean square regression is SSR divided by degrees of freedom. So SSR will be a product of these two. So if you take MSR multiplied by the degrees of freedom, so that will give you, and then when you add these two, that will give you the SST. So that's SSR, SSE, and SST. So now we have the entire ANOVA table for regression constructed from the given information.